Hey there, POE. Today we are going to talk about simple machines. Now, there are three key points that we're going to be working with today. The first off, we're going to talk about the different types of simple machines. That's going to be nice and easy, just the 6 different simple machines. Number 2, we're going to talk about work and why that's really important to us and how we characterize machines. And then lastly, we're going to be talking about mechanical advantage through ideal mechanical advantage, actual mechanical advantage, and efficiency of a machine. So getting started, there are 6 different simple machines, and the way we're going to characterize these is simple machines are mechanisms that manipulate the force and the distance of a certain movement, whether we're trying to lift something up, whether we're moving something across a ramp. Simple machines are messing with force and distance. So the big ones that we're going to be talking about are levers, we're going to talk about wheel and axles, we're going to talk about pulleys, we're going to talk about inclined planes, wedges, and screws. Now we're going to go through all 6 of those throughout the course, but we need to talk about just kind of the basics of what's the point of simple machines and what are some different calculations we can make within each of those. Now the biggest thing that we need to talk about is work. And there's a very specific equation we're going to have to use to talk about work. So work, we're going to put a big fat W, is equal to the force applied times a distance. So if I were to push a box across a floor, something like that, I need to apply a force over a certain distance. That characterizes how much work. So I can put in more force, that creates more work. I can push it for a further distance, that's also more work. So it makes sense. Now, what's really important about these simple machines is they're going to allow us to manipulate the force and distance depending on the situation that we're looking for. So let's say we have a situation where we have, let me scratch that out, we have a box that's just hanging out there on the ground. And our goal is we need to take that box and we're going to put it on the back of a pickup. We're going to move that, something like that. Now there's a lot of different ways that we can get that box into the back of a pickup. We can physically lift it up. We can build a ramp. We can use a pulley system. There's a lot of different ways to do it. It just depends on how much force do we want to actually exert and how far do we want to exert that force for. Now, if you're like me, I want as little force as possible. I want to put in as much of that effort force as I possibly can. And that's where simple machines and work really comes in to help us out. Now, when we're talking about simple machines, one really important distinction that we're going to talk about a lot is simple machines do not decrease your amount of work. They don't increase your amount of work. Regardless of if you use a simple machine or not, your work remains the same. What simple machines do is they mess with your force or they mess with your distance. So let's go back to that pickup example. Let's say that we're going to build a ramp to try to get that box up into our pickup. So we have our beautiful ramp here. And so now we have a couple options to put that box in the pickup. Either we can take that box and we can slide it up the ramp into the back of our pickup, or we can lift that box into the back of a pickup for that distance. So notice how we have this inclined plane, which is a simple machine. And if we are to use that simple machine, notice how the distance that we are enacting that force changes. So now instead of going from here to here, we have a much bigger distance. So notice how putting that simple machine in increases the distance, but what that does, because the work is always the same regardless of if you use a simple machine or not, is if your distance goes up and our work remains the same, that means our force has to go down. So I need to apply less force if I use that ramp. Now let's look on the flip side. If I don't want to use the ramp, and let's say I have that box that's 10 pounds, something like that. Notice how my distance is less to get from the ground to that pickup. So in the case of just lifting it, we have a shorter distance, but that means that I'm going to have to put all of my force into putting that up there. So notice how simple machines do not mess with the total amount of work. It manipulates the size of the force and the distance. And that's a really important distinction that we're probably going to struggle with as we go through the class. So mechanical advantage represents the rough ratio of the force that you're putting into a machine compared to how is that force magnified on the other side. So we can think of it in two ways similar to work. We can think of it as the magnitude of the resistance and effort forces, the ratio of those two, or we can do the same thing with distances. So if you have a high ratio of your effort force compared to your resistance force, automatically you're going to have a lower ratio for the effort and resistance in terms of distance. So if you get a lot of force out of a machine, the distance is going to be very, very low, and vice versa. So when we talk about mechanical advantage and we try to quantify that, let's say we have a machine that has a mechanical advantage of 4. So what that tells us is I could put 1 pound of force into this machine, and it's going to have an output of 4 pounds. So if there's something that weighs 4 pounds that I need to lift, I only have to put 1 pound of force in order to lift that. So we can think of it as the magnitude of my effort force is 4 times less than that of the resistance force. But I like to think of it as more of a force multiplier than kind of a thinking as the opposite. So if I put 1 pound of force in and I get 4 pounds of force out, we have an inverse relationship between the distances. So if my force is multiplied by 4, what that means is I'm going to have to cover that distance 4 times as much. So my force is multiplied by 4, but my distance has to increase by a lot in order to take that into account. Now let's talk about an example of what this might look like. So we have this block and tackle system here, and we're told that we have a mechanical advantage of 2. Typically, when we're talking about simple machines, you're always going to have to label 4 different things: the effort force, the effort distance, the resistance force, and the resistance distance. So let's talk about that 2 to 1 in terms of forces. So let's say that our overall goal is to lift a 100-pound object that we see here. When I put my force into this machine, it is going to essentially double the force that I put in, which means I only have to put in 50 pounds of force to lift something that is 100 pounds, because my mechanical advantage is 2 to 1. However, if I want to lift that object or have a resistance distance of 10 inches, in turn, I have to actually pull that 20 inches. So notice how my force is multiplied, but I'm going to have to pull for a much longer distance in order to actually move that the amount that I want. So there's always a trade-off between force and distance when you are using a simple machine. So we talked about a 4 to 1, we talked about a 2 to 1. When you're thinking about these ratios, always remember that 1 is your magic number. So if you have a mechanical advantage of 1, that means the effort force and the resistance force are the same. You don't have an advantage or a disadvantage, it's just the exact same. If your mechanical advantage is greater than 1, that's a force multiplier. We typically call that an advantage. And that means that we are applying less effort force to overcome a resistance force. Our force is being multiplied. However, if we have a mechanical advantage greater than 1, on the other side of things, we need to impose that force for a greater distance in order to overcome the resistance force. Now, on the flip side, if our mechanical advantage is less than 1, or I should probably say between 0 and 1, that means that I have to put more effort into that machine to overcome the resistance force. But on the flip side is I have to apply it for a much smaller distance in order to come that force. Now notice your mechanical advantage can never be less than or equal to 0. So we're really just talking about greater than 0 and up, but that sweet spot, that awesome ratio is 1. Bigger than 1, you have an advantage in terms of force. less than 1, you have an advantage in terms of distance.